Okay, so in the O2O class, and most of people in 120 are in the O2O that meets at 5:30. We're going to have the final exam, and I'm looking to make it the 16th. So that's about 2 weeks. So that'll give us enough time to finish up this test, and then that little take-home test on 10.1 to 10.3, that is also on the first part of chapter 10. So once we get through that, we be pretty much ready. So in the early class, we will have there'll be a little exam review in there. So I'll show it to you. But you'll have one sort of like we've had for midterm, and here you'll have a review for the final. The final is going to only in the O2O will only be on the first 3 chapters. Okay, through chapter 10. So we'll talk more about that next time once we get past this test. So we've got okay. So the Math 120 test will be next period or next class Thursday. All right. It's going to be on Zoom, so you want to be zoomed in. Make sure your camera's on, and then that way I can just take a look at you while you're taking the test. Okay. Are there any questions?
No.
Okay. So the take-home test is it'll be next week. So what is the 4th? Is that I'm sorry, the 11th? Is that Thursday? I think that's Thursday. Yeah. So it'll be due the following week. So, but you can work on it outside of class. That one. All right. Well, let's go back to
the take home.
what's.
You were saying something.
It'll be due in 1 week. It'll be it'll come to pass. In other words, you're going to see it. I would think by Tuesday, and then it'll be due Thursday before class. You know what? Let's see what I got on it. So it really should be 7 p.m. I'm going to put it a day before that, so you'll have it. I'm going to put it on. I hate to do it on Sunday, but if you need some weekend time, you can start in late on Sunday. If you want more, I'll give it to you. I just hate spanning things over Sunday, but I can't think of a better way to do it. Anyway. What's that?
You do this one at home.
Yeah, you can do this. Well, you're doing most of them at home. I mean, just this one is not synchronous. In other words, it's asynchronous in that you can take it at any time during that. What is it? 5 days, 4 days, period. Okay.
They got a review to it?
Yep. No, there's no review. That's because why you get to take it home.
Okay. Oh, I need my baby.
All right, let me just check one more thing. All right. So let's go back to that review we had. We were looking at. And we just keep going through that as many times as we need to get them comfortable with them. All right, we did that one. So let's go on to number 13.
What's 5 and 4? Oh, all right. Never mind. This one. I was just thinking about this one.
So what's the matter with it? What's
Mm-mm.
you having an issue with it?
It's like when number C, when no vaccine and dog where it complements or where it intersect that, it throws off a little bit with that little line. It just throws me off sometimes.
All right. Now, you remember about two problems back? Let's see, which one was it? It was this one, and I had that formula on there, the formula for conditional probability.
Yes.
Okay. Well, this is really the same thing. It's just that this builds it for you. What does that mean? Let me show you. All right. So we're given a chart, and what we're going to do is we're going to answer each one of the questions. The first one is just plain old probability. We have 70 total. So if you add all four of those up, it'll equal to 70. All right. Now, there's two different groups. There's veterinarians, they work on cats and dogs, and then somebody gave a vaccine to, somebody did not. All right. So the first thing is the probability of a dog. So how many dogs did he treat?
28.
Yeah, so there's
Over
7 plus 21, so 28 dogs. All right. So now 28 divided by
70.
70, and we need to have decimals, but these are going to come out even. So that's 0.4. So 40% of the animals he treated were dogs. Now the second one is vaccine and dog. So that's the one we're looking at. We're looking at vaccine and dog. We're not looking at cats. So these are not being looked at. And we're not looking at that no vaccine for dogs. We're only looking at.
We're not looking at no
Oh,
vaccine.
I'm sorry. It's no vaccine. So we're looking at this one and dog.
And not, yeah.
So we're not looking at this one, or that one right now. So thank you. So it's no vaccine and dog. So now it's 21 divided by the 70. 21 divided by 70. And that's going to give us 0.3 or 30%. All right. Now, remember over there when we were dealing with the gasoline and the oil, the and went in the top, and the given, the one that follows the line, goes in the denominator.
Okay.
All right. So what we're going to do is we're going to take the and, which we just did, 0.3, and we're going to divide it by dog, 0.4. The only two we got.
0.4.
0.
Oh.
0 point. So
Oh, you took
remember,
it off. Yeah.
what?
I understand now.
Yeah, you're just taking the numerator, which is the and, the one we did second, and you're dividing it by dog,
Dog.
0.4,
No.
which is
Oh,
3/4, 0.75. So that's why I wanted to get this one and show you that you don't really need to remember that formula and verbatim. You just got to remember this one goes on top.
no vaccine in dog. Divided. Got you. Oh man, that is so much better.
Mm-hmm. So this is probability of no vaccine and dog. I mean, no vaccine given dog. The dog goes on the bottom, and then the and goes up top.
Thank you.
Let me just finish this out here. So up here, it's 0.3, and down here is 0.4. And then that's really, once it's all settled in, it's 3/4 or 75.75 or 75%. All right. So that's the conditional again. All right. So there's a couple of things here, and I'm going to write them on here that we should remember.
That formula.
Okay. The probability of A or B is equal to the probability of A plus the probability of B. This right here is the addition rule for or.
Subtract.
Thank you.
Possibility A and B.
Mm-hmm. All right. Now, two other things we should know. If A and B are mutually exclusive,
A.
probability of A and B is 0. Okay, because there's no and, because they're mutually exclusive, they're not touching. All right. The other important thing is from chapter 10, section 10.8. If they're independent,
Multiply.
yeah, well, you multiply even if they're dependent, but if they're independent, there's no, it's just a probability of A, probability of B, you get multiplied. But yeah, you got the idea.
Yeah.
So if they're independent, so all we do is just multiply them. Okay, so let's get rid of our dog, and then we're going to go and we're going to figure these out. Now, if they're mutually exclusive, then what that means is that this right here is 0. So for A, probability of A or B is just probability of A plus the probability of B, because the and is 0. So in this case, it's 0.43 plus 0.05, which is what? 0.48, I believe.
Yeah.
0.48. So if they're mutually exclusive, I always like to double check things because I make mistakes, and I'm pretty sure that happens to everybody. So always double check. So 4.48. So for A, this is 0.48. All right. Now, part B, we're going to take advantage of this. If they're independent, then we know that probability of A and B is multiplying these. So I'm going to use the full formula here. All right. So I'm going to fill this in on the bottom. All right. So we already know what the A and the B are, but I'm going to put them there. So 0.43 plus 0.05 minus. Now, remember, we're going by what we had over here, that if they're independent, which is what B tells us in the instructions there, then that means we're going to multiply 0.43 times 0.05. All right. So what I need to do is I'm going to go over here in my calculator and I'm going to multiply those two. 0.43 times 0.05 gives us 0.215. So then to continue on here, this is equal to 0.48, as we saw up top, minus this. What does that give us?
You don't have to do the add. You don't have to add that 48.
We already did.
Oh, okay. There you go. There you go.
See,
Okay.
we added here, and
I see.
that's the answer from up here. And all we're doing now is subtracting this product. We need to multiply that, and then we're going to subtract.
Yeah, you move
So,
fast.
0. I was trying to see if I can get the calculator to see what I'm going to do. The 0.48 is going to have the little product multiplied. So now that's the answer here. So there we go. That's that answer for the independent part.
Okay.
All right. All right. So let me just go over this again just to make sure we understand this. But if they're mutually exclusive, that means that there's nothing to this part. In other words, that part is 0. So that means we're just adding these up, the probability of A and the probability of B, to get the A or B of 0.48. Because they're mutually exclusive. Nothing gets subtracted. Now, for the second one, where we've got independence between A or B, we know that AND is multiplying probability of A times the probability of B. And so that right there then becomes probability of A times probability of B, and that multiplication ends up to be 0.0215, and it's subtracting from this sum, which we know is 48 from up there, 0.48. So when we subtract the 0.0215, we get 0.4585. Okay?
Okay.
All right. Let's see what the next ones are going to give us. All right. Now, I've tried to, as we've gone along, tried to give you an idea of how chapter 2 and 3, they really cover the same topics, because in chapter 2 we had union and intersection, and then in chapter 3 we had and or, which correspond to the union and intersection, and then over here we're using them, and they're even going to give us a problem here where we deal with these like they were Venn diagrams, and so we can see visually how these things work. Okay. All right. So the Venn diagram below shows 11 students in Mr. Diaz's class. They're distributed between the science club, the tennis club, and the none of the above. So these don't fit into science or the tennis, but they are in his class. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students total. So probabilities are going to have that 11 for the. So the probability of A,
So,
which is science club, is we want to grab those doesn't make it easy. We want to grab all those. So how many of those? That's 7, right?
right.
7 that are in the science club, which is what A is. So that's going to be 7 over 11. All right. B, that's these 5 rascals here. That's the tennis club. That's B.
5 over 11.
Okay. So that's 5 over 11. Okay. Now, the probability of A and B,
What they have in common?
that's this here.
3 over 11.
That's these here. Because they are the and people. So there are 3 over 11 in and. And then the or, remember, that's the union.
Everything.
Not everything. It's everything that's in the 2 circles.
Yeah. And it's
Okay.
correct.
It's everything but these 2.
Correct.
So it's Jim, Scott, Sam, Tammy, Manuel, Ivana, Teresa,
9
Trey, and Keisha. So that is 9
over 11.
over 11. That's the or. All right. So now they're asking you, well, what does this mean? Well, that's just going to be the 9 over 11, because that was what they were taking you through, is visually taking you through the or rule, the addition rule.
So B.
So the last question is, what is the name of this?
PARB.
Yeah, that's the probability of A or B. All right. So for the last two problems, see, we've gone back and we've looked at these. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of both. All right.
So or
right
is all of the contents and
Yeah.
is just the middle.
Yeah, and that's why we're adding them up.
Okay.
Okay, it's the or, it's both of them. That's why it's called the addition rule. And then we subtract out any that are alike, anywhere that are repeated. So in this case, those three get subtracted out of the number for or. And then the multiplication rule, that's and. So
With the
that's
diagram,
what we've been looking.
Mr.
What's
Cruz,
that?
with the diagram using the multiplication rule and just what they got in common.
Yeah, well, we don't really use it here. I just wanted to remember, to
Oh, okay.
make sure that we had all of. I mean, that I wanted to make sure you understood those two rules because we used them heavily in the last couple of problems,
Okay.
especially that
So
last one. I think.
3011. Okay.
Yeah, this one is fairly easy because it just means multiply. But this one right here, the addition rule, that's for or. You got to remember that you're going to subtract out if they have, common ones.
Oh.
All right. In a big cooler in the kitchen, there are the following drinks: 6 bottles of soda, 7 cans of soda, 10 bottles of juice, 6 cans of juice. Teresa just came in from playing outside, is going to choose one of these drinks at random from the cooler. What is the probability that the drink Teresa chooses is a bottle or is a juice? Now, we're using this again. All right. We're using this one again. All right. Very common one. Same thing with the multiplication rule, because we've had a number of those too, where we drawing things out. When we come up with the last two are multiplication rule as well. Now, what we're going to do is, I want to try to write this out. We want the probability of bottle or juice. I think I messed it up. I wanted to put it right here. Probability of bottle or juice. And so that's going to be the probability of bottle plus the probability of juice minus both. All right. So I'm just going to fill in bottom here by hand. So how many bottles, how many sodas in total? Or how many drinks total? Let's see. 6 plus 7 plus 10 plus 6. Is that right?
Yes.
So 16, 22, and 7. Is that 31?
Yeah.
I'm going to double check it here.
29.
29?
Yes.
So it's 6 plus 7 plus 10 plus 6. So 29. All right, so get rid of that, and then we're going to put our 29 in. So 29. So that's our total. All right. So now, how many bottles are there? 6.
16. Oh, bottles of soda?
Bottles.
Oh. 16.
16. So there's 16 bottles. Plus how many juices? So now you got 10 and 6. So that's also 16, isn't it?
Mhm.
So she picks a juice, 16 of them out of the 29. Now we're going to subtract out the and so bottle and juice are those 10 right there. So that's 32 minus 10, 22 over 29. All right, so let's kind of go back through this. So I've broken it down because they asked for bottle or juice. So bottle and it's or. So that's why I'm using this formula here. So then the way it breaks down is the probability of bottle or juice is the probability of bottle plus the probability of juice minus the ones that are bottle and juice. And again, we do that because we don't want to count them twice. That's the problem. And like I said, that's what we started doing in chapter 2 when we started counting the number of elements in a union. So 16 and 16 is 32 minus 10 gives us 22 over 29. See any problems with it?
They wanted it in decimal form.
Yeah, they wanted them on decimal form.
Yes, sir. So the nearest hundreds.
So there's hundreds, so that's going to be to the second one right there. Since the third one is an 8, then it's 0.76. Okay? That's the or, using the or rule here. If they've got overlap, they're not mutually exclusive, so that's why we were subtracting those out. All right, so back to one that's going to give us a sample space. And we're simply using the multiplication rule here because what we've got here is a card is drawn random from a 52 card standard deck and then shuffle back into the deck. Then for a second time, a card is drawn at random from the deck. The card is shuffled back into the deck, and then there's a third pick. Okay. So there's pick 1, pick 2, pick 3. Now, are these independent? Here's the key.
Yes.
The card is shuffled, put it back in the deck. So there's going to be 52 cards every time. So these are going to be independent of one another. All right. So what we want is we want red card, then a 3, then a black card. So how many red cards are there?
26.
Half of them are
26 over 52.
26 over 52, or 1/2. Now on this one, see,
So
we're putting that card back in, so there's still 52 cards in the deck.
4 threes.
So there's 4 3s. So there's your 4 over 52. And then this one, also 52 cards, because the cards are being put back in the deck after each one is drawn. And it's a black card, which is also 26. Red card, 26 out of 52. A 3, there's 4 out of 52. Those 4 right there. And then black card, 26 over 52.
So, Mr. Cruz, that,
Mhm.
that's the multiplication formula there, huh?
Yeah, that's the multiplication formula. That's the and really, as you'll see on number 18, they're going to do the same thing without putting it back in the deck, and it's still multiplication. It's just that you have to take pains on each individual pick to determine what what changes with the numerator or the denominator, or well, it'll be the numerator. It can be the denominator or both numerator and denominator. We'll hit that one in a minute. So I'm just going to let the calculator do the work here. I'm not going to simplify them because we're going to do it as a decimal. All right. So 26 over 52, 4 over 52, 26 over 52. So then it's 4 decimal places. So 2 right there. And we're just going to whack it off because the next number after 2 is a 3. Oh, that's a 1. So there we go. Okay. Questions?
Okay.
Yeah.
All right. So we got one more here, and this one is going to be the exact same thing, except the cards are going to stay out. So we're still going to multiply. It's just that we've got that fancy kind of notation that was in the notes. And that's all that this means. Like I said, it still means multiply. But if they're dependent, see, it's just written like this. And that just means with this. So the probability in A and B, if they're dependent, the probability of A times, and all that essentially means is the probability of B given at A is incurred. So you got to take into the account that the picking of A changed the dynamics. In other words, we're going to see now it's going to change the numerator and the denominator and possibly the numerator. All right. So a card is drawn at random from a standard deck. The card is not put back into the deck. And a second card is drawn at random from the remaining cards in the deck. Neither of the cards drawn are put back. And a third card is drawn at random. So 3 cards. So this is what we call without replacement. Okay. So meaning that the second and third picks are dependent on what happens on the first one. Oh, what was I going to do here? Oh, pick one. Pick 2. Pick 3. All right. What is the probability that the first card drawn is red? The second card drawn is spade. And the third card is also a spade. All right. So on that first pick, we've got 52 cards. We've not pulled anything else now. We want to have a red card on the first one. So that's exactly half, right?
Right.
All right. Now the second pick. Once we take that first card out, there are no longer 52 cards in there. There are 51 cards. All right. Now we're doing spades. So now the first card to go out was red. So it's not a spade. So the numerator of this one is not affected. So there are still how many spades in there? All of them, which is 13, right? 13 spades. Now, none of the first 2 are put back in there, so this denominator goes to 50. But now, in the numerator, because we're picking another spade now, and we've already gotten a spade,
12.
there's 12. And so this is the conditional probability. I'm sorry, dependent probability. It is conditional because the second pick takes into account that we pull one card out of the deck that was red. The second pick reflects that there are now 51 cards in the deck because one of the red ones is gone, but there's still 13 spades in there. Because if we're going to have 2 spades, we got to have one first. And then on the third pick, since we got to pick the spade on the second pick, then now there are only 12 spades left. And there's 50 cards left because we already picked 2. So now we are ready to multiply. So 26 divided by 52 times 13 divided by 51 times 12 divided by 50. So see how it's sequential there in the denominator, 52, 51, and 50. And then the same things happened up here in the numerator because these last 2 were spades. So the second pick, we have to assume that it was a spade because that's the only way we're going to get 2 of them. So for the third pick, there's only 12 spades remaining out of the 50 cards left in the deck, with the 2 missing that were picked. All right. So let's see what that's going to give us. So it's 4 decimal places. So that gets bumped up 0.0306. The 5 becomes a 6 because its neighbor to the right is 8. And if it's 5 or above, that means bump up. Okay. Any questions? All
No, sir.
right. All right. Well, let's go back and look because there's a few other people here. Plus, if you came in late, you might have missed on something.
Can we go over
Yep.
number 11 again? I still don't understand it.
Yeah, that's a good idea. I don't remember what it is, but what is it? Okay. So we're dealing with the same thing we dealt here in 13. Okay. Let me kind of go through 13 just briefly. And then I'm going to also write the formula here. Okay. What this
Remember-
problem,
Oh,
I'm
sorry.
going to go back to 11, but I just
okay.
wanted to explain. Did you got something?
For number 11, the main part I don't understand is the way they word it. I never know. when
Okay.
it's, like,
Yeah.
switching
I'll
out.
try to go through that too, but
Yeah.
let's just, since we're going through it, I want to make sure that we understand we're dealing with this. The probability of
Okay.
B given A is this. All right. The probability of B and A, and down here is the probability of A. So what that means is the condition is what goes in the bottom, whatever the condition is. Now, in this case, the little line right here means given. So this means no doxine given that it's a dog. And that's why we were easily able to take the 0.3, and put it over the dog, and that was the 0.4. And that's how we get the 0.75. Okay. So now let's go back over to 11. Because you're right that the wording changes sometimes. Sometimes they'll use given on both of them. Sometimes they'll word it slightly different without given. They'll use it as a condition. All right. All right. Now, okay, well, let's see if we can get a new one. I would do this one again, but we just did it and they got both given. So I wanted to show you one where you don't have the given. So that's probably what you're asking about. So that's why I want to see if I can get us a different one. But this is what we're using. All right. So I'll tell you, there's a couple of different ways to do it. Okay, on A, it says, what is the probability that a random chosen stock investor also invests in fixed income? So B is, what is the probability that a randomly chosen U.S. adult invests in stocks, given that he also invests in fixed income instruments? All right. So I'm going to just put over here those values from up top. The probability of stocks is equal to 0.29. The probability of I'm just going to put income, shorten it, is 0.24. All right. And then the probability of both is oh, I'm sorry. This is the point both. This was the fixed income up here. All right, let's on that. Saw that. Just make sure you're ready for ours. We're going over stuff we already went over. So if you got it. All right. So if I got those right, 29% invest in stocks, 88% in fixed income, and then 24% invest in both. All right. So this one here, B, is a little bit easier to figure out because it has the word given in it. All right. So given fixed income. So that is going to be the probability of stocks given fixed, what was income is what I was using. All right. So then what that's going to be is
24.
so up here, it's the probability of stock and income. And then down at the bottom,
Stock income. I mean, invested
it's
in
income.
stock.
It's what follows the line. It's what follows the word given. That's the condition. Do I have them set up right? Let me just make sure. What is the probability that a randomly chosen U.S. adult invests in stocks given that they invest in fixed income securities? So the given, the condition is income. So that goes on the bottom. All right. So then we've got those values written over here. Okay. So in the numerator,
Oh, I was looking at the first one. Oh, sorry.
so the
Okay.
numerator is going to be the both. All right. And in the denominator, it's the income.
Oh, I was working on A. Okay.
Well, the reason why I'm doing this one because it's easier because it's got the word given in it, and that
Right. I'm with you.
kind of helps.
Mr. Cruz, I'm
All
in
right.
and out
And then I'm going to,
I'm ducking out. So,
all right. So now
okay.
that's going to be, then I'm going to show you how I'm going to use that to help me with the first one. So 0.24 divided by, oops, 0.24 divided by 0.88. So this is,
Round it to the 100, please. Stay the same. 0.27.
okay. So this one ends up being 0.27. All right. So now on A, what is the probability that a randomly chosen stock investor also invests in the fixed income securities? Now, the order is the same, but this time, let me see if I can read it slightly different to help you. If the investor invests in stocks, if stock, then income. So the way that's going to shake out is like this. It's just the opposite. Because now they're saying just only look at stock investors now. What is the probability that a randomly chosen stock investor, that's our condition, also invests in fixed income securities. Now, one of the reasons why I did the other one first is because it had the word given in it, and that clearly indicates, because the given was income, so that means that's our condition that goes at the bottom. Well, these two are not going to be the same, so this one is intended to be the opposite. They're opposites to one another. So this one is going to be up in the numerator. It's going to have the same thing because that's the way these work. All right. And then down here now, it's stocks. All right. So in the case of both of these, the numerator is the same because whether it's, you got the same two elements anyway, so it's 0.24. But what changes is the denominator, and the stocks was 0.29. So here, another way of reading this top one is, given stock investors, what is the probability of there being fixed income? So, like I said, the wording is different, but they're giving you a condition there, and that condition in this case is this. It just does not use the word given, but that is your condition because they're laying it out first. So if it doesn't have the word given, then look at the first thing mentioned, which in this case is, what is the probability that a stock investor, or we could say given that they are stock investor, or if they are stock investor, then what is the probability they invest in fixed income securities? So if there is no given word there, then I would say, as far every one of these I've seen, your condition is what's given first. That's why these end up being backwards. And the reason why I did this one first is because it had the given to give me the clue of how to set it up. The given clearly indicates the condition, and that goes at the denominator. So the given was income, fixed income instruments, so that goes down here. And then in the numerator is the both. And in the case of each one of these, that both goes up at the top, and it's the same. The only thing that changes is the denominator, because in this case, the condition was income, fixed income, and on this one, the condition was stocks. Does that help, Nick?
Yeah.
Even though in B it says invest in stocks in the first part, why do you put income with it? In the
Okay, in B,
in the numerator for B.
because of this formula here. This is the formula for conditional probability. The condition goes in the denominator, and then in the numerator is the intersection, or the probability of the intersection of the two. That's why in both of these cases, that intersection is in the numerator, and what changes is the condition. So the given tells us the condition, or the denominator is the fixed income securities. That's why it's here. And so up here, there's only one other thing it can be. It's going to be the stock, because the and always goes in the numerator. And you can take my word for it to the bank. Both of these are conditional probability. Sometimes I've seen them where they'll have two of them without the word given. So use the first thing that they mention as your condition. All right, we can see if anybody wants to go over any of the other ones. We got a few minutes left, so usually the first couple of are pretty easy. So this was the one combinations and permutations, but it's probability, so it's 1 over. Okay.
What was 5 and 6? We skipped.
What's that?
What was 5 and 6?
I didn't think we skipped
did
anything,
that.
did we?
Yeah.
That's the odds. Let's go over one of those again. We've got a few more minutes because this is the one that gives sticking here. All right. So they want us, they give us this 10 slice thing, some black, some white, some gray. So what happens is if the arrow stops on a white slice, then Han wins a gift card. So we want to find the odds in favor of Han winning a gift card. So what we got to do for both of these, because the other one is odds in favor. So we need the probability that he wins a gift card or a white slice. So what's the probability of a white slice, which is what gets him the gift card? 2 over 10 or 1/5. All right. Now, in order to do the odds, we got to have the complement. We got to have the probability of not white. Oh, I was gonna. The student, she left. I ran into that teacher today that does that wine appreciation. The hard teacher. She's over here in the building, and we had our power out on the West Bank, so I had to go over to that building. I met that lady, but she said, yeah, that she turned it into a hard course where you got to write. Sort of like nobody likes to write, like they don't know how to do math. That's why she's big on the writing. Anyway, I got to meet her, but I think the student was left. That was who was that? Another name when I see it.
Like 8 to 2. 1, 2, 3, 4, 5, 6, 7.
All right. Oh, anyway, let me finish this. So not white. What's the probability of not white going to be? 1 from 5. So how do we know that? Well, we use the complement rule. 1 from 5 gives us 4. And you can also see this. The ones that are not white is 1, 2, 3, 4, 5, 6, 7, 8. 8/10. So that's what gives us also the 4/5.
Gotcha.
But as I said, this is that question that people were asking me about when do you subtract and when you add. Well, when you're going from when you go into odds from probability, then you got to subtract. So 1 from 5 gives you the 4/5. So now A is equal to 1, B is equal to 4. And that's all we need for odds. So now odds in favor is A to B. A to B. Odds against. Okay, so they just switched around. So for this one, it's just going to be 1 to 4. And then you just turn them around, 4 to 1. All right.
Yeah.
All right. Anybody want to see anything else?
Oh, finish the whole number. No, sir.
We got a couple more minutes. Let's just see if you. I was trying to scroll through, and if you can yell if you want to see something else.
Hmm. Mm-mm.
All right. So we'll have time before in the 5:30 time. So if you got any more questions about from this, bring them. All right. And then at 7 o'clock, make sure to get on Zoom with your photo, with your face visible. All right. While you're
Alright.
taking the test. And then I'm going to sit here and watch y'all guys. Okay.
Okay.
So we got a few minutes left. If you need anything, just hang on, hang out. Just stick around and I will be glad to talk to you.
We're taking test 3 during class on Thursday.
Yes.
It says that test 3 is due before 12:15.
Yeah,
and
I probably got the wrong time on them. I had the wrong time on all of them. I can change it now.
Okay, thank you.
Because I also got a class that meets at 9 in the morning, 9:30, and I must have copied it and didn't change it. And there we go. That'll do it. 7 p.m. to 8:15. Thanks, Nick.
Mr. Cruz, I see you at 5 or 5:30.
All right.
We got one more person out here. But they
Yeah, I
might-
know. I was trying to think. See, the test is at 7. So if you start at 6:15, that'll give you, your time and a half.
All right.
But this is the problem. Because I wanted you to be on Zoom. I need to think of a way to do that. Maybe I'll just start it because I don't want other people going, well, I'll just come around 5 and we'll talk about what we need. We'll just get on Zoom and chat about it or email. But I got to figure out a way because we're spanning 2 classes, so I don't want you to have to do too much during that time. So I got to figure out a way to do that.
We will be going over what we get ready to test for, right?
Right. So what I might do is just open up
I
the
didn't hear you. You breaking
second
up.
class. What I may do is just open up the second class early for you, and you could go in before the other one ends. Okay. So just come around 5. I'll be, handling office hours, and then I'll give you better instructions in. Okay.
Okay. All right. Good night, sir. Thank you.
All right.
All right.
Thank you, Mr. Cruz.
Okay. Bye-bye.
Bye-bye.